Okay, so last time we were here, we began our look at the algebraic system, right? We did our introduction to algebra, and so there were a couple of things we talked about. One of the things we talked about is that we no longer have just numbers to build our system, right? We have what are called terms. Right? So our building blocks for the algebraic system are called terms. And when you have terms, all terms have exactly how many parts? You can remember. 4 parts. Good job. 4 parts. Listen, guys, it's so important that you understand the 4 parts and how they are put together. If you do, then algebra is so easy for you. Because what most of algebra is we are going to spend our time taking things apart. So if you know how something is put together, do you think that would make it easier to take apart?
Yes.
Absolutely, right? So pay close attention to how things are put together. And that's what we're going to spend this week and next week doing, is looking at how things are put together. And then when we come back in term 4, what we're going to do is we're going to spend that time taking them apart. All right? Which is the basis for all of problem solving equations, etc. What is the first part of every term?
Sign.
The sign. Excellent. Good. Remember that those pluses and minuses for us still mean addition and subtraction, but in reality, as a part of a term, it's the sign. And if the sign is the first part of every term, then we can also know when one term stops and the next one begins every time we see a plus or a what? Minus. So if you see a plus or a minus, you know that one term is stopping and the next term begins. Mm-hmm. Okay? Oh, she's ready. Okay. So what's the next part then? The coefficient. Now be careful here, because the coefficient of the term is the number part, right? But in reality, the word coefficient means a multiplier. But the multiplier of a term is always the number, right? How many of something we have. And so remember that those 2 pieces of the term are taken together and literally tell you how many of something you have. Just like at this table, we have 4 students, right? Okay? So the 4 tells you how many. So it's 4 times student, right? Gives you 4 students, doesn't it? Third part, anybody? Be careful, it's got a special word. It's not V. It doesn't start with V. It starts with B. What is it? Base. Excellent. Good. But because we're talking about algebraic terms, the base is always a what? Variable, which just means a letter, right? So be careful. The base is what it is, but the base of every algebraic term is a variable, okay? Which simply means a letter, right? And that's the whole difference between algebra and arithmetic, the introduction of those letters. And on every base, whether you see one or not, there is an exponent. Good. An exponent. What are some of the other words for it? Power. Excellent. Anybody else? So there's another one that's used in y'all's books a lot. Index. There you go. And most New Zealand math books that I've seen have been calling them indexes, or indices is the plural for that, right? An index for power. Okay, good. And I don't care which one you use. You know me, I usually say exponent or power, but I'm trying to learn index as well, so that way, remember, half the battle is knowing what the directions are. If you know what the directions are, then it's a lot easier to do what you want to do. Yeah? Okay? So, good. All the parts of a term. What if I have one of these? What does a constant term mean?
Does it mean it stays the same?
It stays the same. And what kind of things always stay the same?
So like just a plain number.
Just a plain old number, you bet. 7, 2, 3, etc. Numbers, just plain old numbers, like we used to use in arithmetic, are called constants because their value can never vary, right? 7 always means 7. We know what it means. It never changes. However, A could mean 10, 50, 5,000, right? So its value can vary. Okay? Remember the boat thing we had where the engine was always going a certain speed? That speed was constant, right? But the wind could blow at different rates. So that was a variable. Excellent. Well, so we've got our different things that make up the algebraic system, right? So now what we want to do is today what we're going to do is talk a little bit about how we write things. Because how you write things in algebra is a little different. Because algebra, you can do lots of huge, complex mathematical ideas with algebra, right? So if that's the case, we want to be able to write as little as possible. So instead of saying the wind was blowing, so many miles per hour, we would say W, right? So to replace it. And the same is true when we're dealing with some of the operations. So let's talk a little bit about some of the operations in algebra. And the one that changes more than any other is multiplication. Multiplication can be written in a lot of different ways. And we're used to writing multiplication. If we wanted to say multiply, most of the time we would use that X to represent multiplication, right? But we kind of touched on this last time. Why is X a problem now?
Because you might get mixed up with the X.
Exactly. I don't know if that's X the multiplication symbol or X the variable, right? So it's very difficult. Now, your books will still use multiplication symbols, the X for multiplication symbols, and I will too. But instead, more often than not, we replace that multiplication symbol with a dot. So get used to that notation. You'll see it as you move forward in mathematics. It'll suddenly appear, and so you need to know what it means. But notice that I have a number times a letter here, right? Well, there's even another way I can write this. Instead of writing anything at all, how can I write it?
4A.
Right. I don't need a symbol at all. And that's because anytime you have two things side by side like that, it always indicates the operation of multiplication. Now, multiplication is the only operation you can do that for. I can't suddenly take 4 plus A and write that as 4A. That is not correct, right? The only operation that requires no symbol at all is what? Multiplication. And that's really important for you to understand. So if I don't see a symbol, what do I automatically assume? Multiplication, right? And that's going to happen to you from now on. They're going to not write a symbol at all. And so they just assume that means you know that means to multiply. Okay? You can also use parentheses to represent multiplication. Or brackets, I'm sorry, you always call them brackets. Notice that there's nothing between that the first bracket and the second bracket. That means that what I really want to do is multiply. Okay? And we'll talk about that more as we go as well. All right? So, you can see a dot. You can see but more often than not, you're just going to see things crammed together. Okay? Now, could I do that same thing with numbers that I did with the 4A?
But otherwise it would be 26.
Right. I can't just put nothing between them because then it doesn't say 2 times 6, it means 26, which is changing the value. So we can't do it with constant terms, right? We can only do it with algebraic terms. Okay? Good deal. The other operation that changes a little bit is the operation of division. Now, you will still see, y'all are so good, you will still see the division symbol, okay? Let's see if we can get somebody else. But what's another way of writing division?
Something by, fractions.
Exactly. We could use the fraction bar to represent division. So if I wanted to say 4 divided by a, I could just put it as 4 over a. And if you look at the division symbol itself, it looks like a fraction, doesn't it? It's just a fraction bar with 2 dots. And so this is how division started. And then someone just said, hey, you know what? Fractions scare people too much. Let's use another symbol to represent the division. But in reality, fraction just means to divide. So if I have 8 over 2, that literally means 8 divided by 2, which is what? 4. And the way you get fractions is you have some division problem that you can't actually divide. Can you divide a 3 by a 5? Nope. So that's where 3/5 comes from. And so fractions simply mean division problems that you can't do the division. Now, sometimes you can, but you can't always. Looks good? Okay? So our lesson today is all about simplifying, making sure that everything is as clean as you can get it. If you don't have to write it, we don't want to. Okay? This is the one time you get permission to be lazy. So yay! You always have it? Okay, well, we'll see. All right, so let's go to our lesson just and walk through it. We've talked about most of the topics. But what I want to do is I want to just go through so that you can get used to the terminology and the language that they use, right? So that you can when you're doing your homework. Now, another note about homework. Let me turn off the recording. Sloth is back, of course. So now we've seen what variables and expressions are. Remember, an expression is just a combination of terms and operations with no what? An expression can't have an equal symbol, right? Because that changes it to an equation, different type of thing. So what we're going to talk about is with the rules for making things as simple as possible. Okay? I guess that's where they get the sloth from, because math teachers want everything to be simple. Oops, sorry. So,
I don't think that's true.
there are... come on. It's my whole life just to make your life easier. You didn't know that? Okay. So, there are certain conventions about the proper way of writing things and doing things. You're used to one of them, the order of operations, right? Do you just get to do whatever operation at any time you want to do? No. So that's one of the conventions or rules of mathematics, is making sure that you're following certain rules. And so here's, for example, is another one. Which side of the road do you drive on in New Zealand?
Right.
You're not going to be driving very far if you're on the right. But do they do that everywhere in the world?
No. Yes.
No. Some places they drive on the other side of the road, on the right side, right? Like America, yeah, like me.
Is it weird driving in New Zealand now?
Yes, it is. It's very strange. It's very hard to take a right turn without just turning into that first lane that's closest to me, which could be a bad thing, right? Yeah. All right. So one of the things you already know how to do is you know some things about multiplying by 1, right? And so let's look at what they're talking about. So 3 times 1. What is anything times 1 is always going to get what? The same number again, right? So 3 times 1 is still equal to what? 3. We also know that when we're multiplying, we can flip the order of the problem, right? And it makes no difference to the answer, does it? So 1 times 3 is still what? 3, right? So that's a convention in mathematics, that multiplication can be done in any order. Does anybody know what rule that is? Then there's a name for it.
Upside down, turn around.
It's called the commutative property. Ooh, what a nasty word that is, right? Commutative property. Okay? You can look those up if you want to. All right, here we go. Now, you can also say that if you have 3 of something, if you put them together, right, instead of 3 lots of 1, you have 1 lot of what? 3. And it means exactly the same thing. Yeah? Okay? So being able to understand that there are different ways to write exactly the same thing is going to be very important to you as we move into the algebraic system.
What's that one called?
That's still the same thing, the commutative property. So working at them, right? Because you can write the same thing in different order. I mean, the way you say it doesn't matter. Okay? Also, another convention that we need to talk about in algebra that we may have talked about, but if we didn't, that's fine. If I have this thing, what is this?
Pen.
Well, isn't it one pen?
Who said a pencil? A pencil?
Do we need to say one pen?
No.
No. If you say the name of an object, we all assume that you mean how many of them?
One.
So if I say stapler, you assume how many?
Two.
One, right. It's always fun. Okay? So, if I say phone, you assume how many? One. Exactly. And the same thing happens when you're dealing with X's and Y's and A's and B's, etc. So if I say the letter A, that means you assume how many? One. So, if you have a letter, any letter at all, and it doesn't look like it has a number, a coefficient in front of it, it really does. A is the same thing as 1A. Okay? So X is the same thing as what? Well, 1X. There you are, right? So anytime you have a letter all by itself, it's the same as saying you have one of them. Right? So if you don't see a coefficient, what do you assume that coefficient to be? A 1. Hugely important in algebra. It's really easy, right? But you've got to make sure you remember. If you just have a letter. So if I have a B, how many B's is that? One B. Okay? Makes sense? Good. There's not a special name for that one, right? Okay. But I'll give them to you first. So, why would you write 1x as just plain old x, do you think? Right. They mean the same thing, and it's shorter, right? So, they mean the same thing, and it's shorter. I just did one of your homework problems. I got to stop doing that. Now, here's a good example, though. Guys, here's a good example, though. Would there be anything to write here? No, this is not one of the ones I'm talking about where you're showing your work. I don't want you just rewriting everything. I just want you to write it if there's something to do. So if there's some addition to do, for example, then I want you to write on the addition on paper for me. Even though some of these, like if it's 2 plus 4, you could do it in your head. I just don't want you to get used to not thinking that the work has value.
What do you mean by doing it on top of the wall?
Well, I'm saying you'd write it on paper instead of just typing it in. So like if I said, if the problem came up here and it was 2 plus 4, would you write anything down? No, you just type in the 6, right? But where I really want you to write down the 2 plus 4 and then the 6. Now, that's a terrible example because it's too short. But what's going to happen is we're going to get to problems where there's just too much to do in your head. And I want you to be in the habit of writing it neatly and doing it neatly. Okay? All right. Let's find the next lesson part here. Okay? Here we go. Another shortcut when you're talking about multiplying a number and a variable is simply to leave out the multiplication symbol. I don't like it that they call it a sign. It's a multiplication symbol. What's the difference between a sign and a symbol? Signs mean either positive or
Negative.
And a symbol is an operation, right? It's a shortcut that I don't like that some math books take, but that's just me and I don't write math books. Maybe I should, huh? Okay, maybe we'll all do that. We'll just get together and write a math book one day. So, instead of saying 4 times x, what can I say? 4x. Okay? The same works with letters. Instead of saying A times B, what can I write? AB. Good. If you don't have an operation symbol, you automatically assume it means to multiply. This good? All right. So like I said, we've done most of these. So 4 times x means 4x. Now, here's something interesting though. Technically, right? Are you listening, guys? Technically, is 4x and x4, do they mean anything different? No, because the commutative property says it means 4 times x or x times 4, right? So technically, they don't mean anything different. But here's another convention. The convention is that we always put the number in front of the letter. Because could you say cars, 3, and still mean 3 cars? Yeah? But it sounds pretty stupid, doesn't it? Okay, there you go. Yoda, he's pretty smart, but, he doesn't speak English very well. So, even though they have the same meaning, we always put the number first. Did you have a question? Or just a comment about it? Okay. All right. So, we always put the number first. One of the reasons we do that is because later we're going to have things like where we have 4x and 5x, etc. in the same problem. Well, if one of them was x4 and the other was 5x, and you just could put it anywhere you wanted to, you might not recognize that they mean similar items. Okay? So always write the number when? Before the letter first, you betcha. Good job, guys. Okay? All right. Now, you can rearrange them in any order because multiplication does not matter, right? 3 times 4 is the same as 4 times 3. We talked about that a second ago. Okay. All right. Here's where they're showing you that you can't just leave out the multiplication symbol with numbers because 3 times 6 is not the same thing as 36, is it?
Yeah.
Okay. All right. Whoops. Now I'm into your homework. We're not doing that. And last, let's talk about the division. And again, we're just going to be talking about writing it differently. If you're dividing something into 4 pieces, one thing divided into 4 pieces, you could write it with the division symbol. But remember, in algebra, we're lazy. We don't want to write anything we don't have to. So instead, what would we write? Instead of 1 divided by 4, 1 over 4. The fraction 1/4. Right? And we've already talked about, remember when we were doing those formulas for geometric shapes, the area, that multiplying by 1/2 is the same as dividing by 2, right? And this is why that makes so much sense. Now, when you see this, dividing by 4 is the same as multiplying by 1/4, because dividing by 4 is the same as 1/4, isn't it? So that's why they work so well like that. Good. Okay? So here I have 3 things divided by 4. So instead of saying 3 divided by 4, how could I say that? 3/4 or 3 over 4. Either way you want to say it. You bet. Good. Okay? So what if I had an unknown number of things divided by 4? So they saying P because it's pizzas. Well, how could I write P divided by 4? Just P over 4, or P4. Exactly. So it doesn't have to be numbers to be a fraction. Okay? As a matter of fact, you could have all variables, and it's still a fraction. It still means to divide. What does x over y literally mean to do?
X divided by y.
X divided by y. Good job. Okay? In stereo even. Okay? So there you see that same example. All right? Now, so instead of writing 3x divided by 7y, what would I write in algebra?
X over 7y.
There you go. 3x over 7y. Okay? So it doesn't matter how big or how small it is, always you just write it as a fraction. Now that brings up something.
No.
In algebra, that slash, that forward slash, is the symbol for or. So this means 1 or 2. So make sure when you're doing your fraction bar, it's always flat. Okay? Because think about if we had 3 divided by a plus b, for example, that means 3 divided by all of that stuff, doesn't it? Not just part of it. And so if you use the slash, it would look like that. What does it look like the 3 is being divided by now? Just the a part, doesn't it? And it looks like then you're adding the b. Okay? So, but if I wrote it like this, it's very clear that it means divide it by the entire a plus b, not just part of it. Okay? So if you're in the habit of using that /, get out of the habit of doing it. Okay? All right. And when you have children of your own, tell them that's not the way to write those fractions. All right. Just don't let them do it in the first place. Oh, there we go. Okay. Is that a sloth, though? What is that?
That's a sloth.
Oh,
Oh, yeah,
okay.
I love that one. It's called Alyssa.
There you go.
Yeah, I can do it to you. Because you mean to doing it with
Tiger looks very annoyed. Okay, what else? What else? There we go. And then mixed algebra, if you want to work on those, it just kind of expands things a little bit more, puts things all together. You're more than welcome to work on those with the target. Those, again, are just a bit more of the same, but putting things together. Okay?